All right, so we're going to talk about adding and subtracting polynomials. So in order to add or subtract polynomials, we first have to look for what is called like terms. All right, so what are like terms? So let's look at some examples. So like terms means the term has the same variable or variables. Sometimes terms have more than one variable, right? So same variables and the same exponents on those variables. Exponents on the variables, okay? So for example, 3x and 5x, those are like terms because they both have the same variable, which is x, and those variables have the same exponent, which is 1. So those are like terms. So we could add or subtract or combine those two terms because they're like terms. So these are examples. Let's do some non-examples over here. Okay, if I have 2x squared and I have 4x, okay, these are not like terms because even though they have the same variable, they both have x, this one has x squared and this one is just x to the first power. So those are not like terms. Another example of like terms would just be numbers like 5 and 7. Those are like terms even though they don't have variables and they don't have exponents. They're the same because neither one of them has the variables and neither one of them has the exponents. If I have 3x to the third plus 7x to the third, and 7x to the third, those are like terms because they both have x and they're both raised to the third power. If I have 2x to the third and 3x squared, okay, those are not like terms because on this one x is to the third power, on that one x is squared. So those are not like terms. What else? Let's do, if I have 5x squared y and 2x squared y, those are like terms. They have the same exact variables. They have the same exact exponent on each variable. So those are like terms. By the way, even if I had written the second one as 2yx squared, okay, those are equivalent and those are still like terms. Even though the variables are in a different order, they are still like terms because they both have the same variables multiplied in there with the same exponents on them. An example of something that's not a like term might be 5x squared y and 2xy squared. Okay, here it's not just the order that changed, that I put x and y in, but it's the variables exponents that changed. On this one, x is squared, and this x is not squared. The first one, y is not squared, and the second one, y is squared. So those are not like terms, but as long as the x's are all squared and the y's are all not squared, then they're like terms, okay? So that's what like terms are. So as we're going to add and subtract our polynomials, we need to be looking for like terms. So in this first example, these parentheses are here to tell me that this is the first polynomial, x cubed minus 2x squared plus 9x. That's a trinomial, right? Because it has 1, 2, 3 terms. It's a trinomial that is degree 3 or cubic. And we're going to add it to this binomial, right? This has 2 terms, so it's a binomial. It has degree 1 because I don't see an exponent on x, which means it would be 1. So we're going to add a third degree trinomial and a first degree binomial together. So in order to do that, we need to look for like terms. So a like term, again, remember, means they have the same variable, they have the same exponent on the variable. So what is a like term here with, if I get off my eraser, with x to the third? Now there are no other terms here that are also x to the third. So since that one has no like terms, I'm just going to go ahead and write that one down right here. And then I'm going to go on to my next term and I'm going to look for like terms. Let's make this one purple. So I'm looking for squared terms. All right, well, there are no other squared terms. So again, because negative 2x squared has no like terms, I'm just going to write it down just the way it is because there's nothing here that I can add or subtract or combine with it because there's no other squared term. And then we're going to go ahead and we're going to look at 9x, just 9x, and negative 7x. like terms. They're like terms because they both have x, right? So if I take 9x and I subtract 7x from it, 9x minus 7x is 2x, and I'm going to add it onto my polynomial down here. So 9x minus 7x is 2x, so that goes here, and then 9 has no like terms, so I'll just write plus 9. So now I have x to the third minus 2x squared plus 2x plus 9. This is in standard form, which I would like you to write your answers in standard form. Remember, that means highest exponent first, and then going down in descending order. That one would be a 1, and then no exponent. So once you've added it together, if it didn't naturally come out in standard form, I want you to put the answer in standard form. Okay, and then just in way of review, what is our leading coefficient here? Remember, the leading coefficient is the number in front of the variable of the leading term. The leading term is x to the third. I don't see a number in front of it, so that number would be a 1, right? So our leading coefficient is 1. And our constant is the term with no variable, so it would be a 9. Okay? If I were to classify this, it's just a polynomial, or a polynomial with 4 terms. We can't call it a monomial, binomial, or trinomial, but we just call it a polynomial, and it is third degree or cubic. Okay. Let's look at the next example here. Again, we're looking for like terms. We have a trinomial, and we're adding a polynomial with 4 terms. We're going to go ahead. I like to start with the highest exponent term that I see, but you can certainly just go left to right. I'm going to start with x cubed because that's the highest one I see. So negative 2x to the third has no like terms here, so I'm just going to go ahead and write it. This way it's going to be in standard form automatically, and it's kind of just a systematic way to go about it. So I'm actually just going to cross that one off because we've already used it. And then I'm going to look at terms that are squared because that's 1 down from cubed, right? So I have a negative 8x squared here and a 5x squared here. Those are the only 2 squared terms. So I can go ahead and add those together. Negative 8x squared plus 5x squared. Well, negative 8 plus 5 is negative 3. So negative 3x squared would be my next term. Again, I'm crossing them off just to stay organized and make sure that I get each term accounted for. Okay, so then we'll go ahead and we'll move on to x terms. So we have 3x and x. So 3x plus 1x. Remember, if you don't see a number in front of it, it would be a 1. So 3x plus 1x is 4x. It would be positive, right? Because they're both positive. And then I have the 6 minus 4. So that would be plus 2. Again, because I started with my highest exponent terms and then went down sequentially from there, this is already in standard form. So it's a polynomial with 4 terms. The leading coefficient is negative 2. The constant is 2. And the degree is 3. All right, let's try one more. So we have a polynomial with 4 terms plus another polynomial with 4 terms. I'm going to go ahead and start with the x cubed because those are the highest exponent terms. 6x cubed minus 4x cubed is 2x cubed. Okay. Then I'm going to move on to my x squared terms. If I can get a different color. So negative 2x squared and 8x squared, those are like terms. Negative 2 plus 8 is 6, so this will be plus 6x squared. That takes care of all of those. Then I'm just going to make these ones underlined with a different shape. So x and negative 5x are like terms. So x minus 5x, that's 1x minus 5x is negative 4x. And then my constants are 3 and 6, and 3 plus 6 is 9. So there is our result. All right, so now notice we have not a plus sign in between the parentheses, but now we have a minus sign, right? If we look at the previous example, in between our parentheses we had a plus. Now on this one, in between our parentheses, we have a minus, right? So there's a lot of pluses and minuses when we're dealing with polynomials. So we really need to think about what operation is being asked, and that can always be found by looking between the parentheses, right? If there's a minus between, it means we're subtracting all this stuff that comes after in the second set of parentheses away from the first one. If there's a plus in here, that means we're adding the polynomials together, so all the terms will get added together. If we're multiplying, we won't see anything there, right? It will just be a parenthesis and then another parenthesis with nothing between. That's how we'll know we're multiplying. So we really need to pay attention to what's between the parentheses. Which operation is it asking me? This one is asking me to subtract. Now, it's asking me to subtract everything in this group, right? These are a grouping symbol, and they're saying take this group and subtract it from the first one. So because of that, I have to think about this, or one way to think about it is this is a -1 out front, and I'm going to distribute that -1 into the parentheses first before I do the operations. So I would have x to the third minus 4x squared plus 9x, and then if I have -1 times -7, that becomes plus 7x, and then -1 times +5 becomes -5. Okay. So think of it as I'm subtracting all of this stuff away. If I subtract a -7, that becomes a +7. If I subtract a +5, that's just -5. But distribute that negative into the second set of parentheses before you begin. I like to rewrite it because it makes a lot less mistakes. There's a lot less room for error when you just rewrite the terms. Instead of trying to like change all the signs in here, it gets messy, it gets confusing. So if you want some advice on how to not make a mistake here, rewrite the terms, okay? So now I'm looking for like terms. X to the third is the only x to the third there. Same with x squared. So there's no like terms with x to the third or x squared, so those will just stay the same. 9x and 7x are like terms, so I can add those together. 9 plus 7 is 16, and then -5. So there is our polynomial result of the subtraction. Okay, again, subtraction between, so I'm going to carry that negative to all the terms that come after it. They're in the second set of parentheses. So -8x squared plus 3x plus 6. If I have minus a -5, that becomes plus 5x to the third. Minus 2x squared. Negative times a positive is -x, and then negative times a negative is plus 7. Okay, again, rewrite it, make sure your signs are all correct, and then look for like terms and just add them up. That one's the highest one, there's no other x to the third, so I'll write that one first. -8x squared minus 2 more x squared would be -10x squared. 3x and -x, so 3x minus 1x is 2x. That gets rid of those two. And then I'm just left with 6 plus 7, which is 13. Okay? So again, if you're adding, you can just start right away looking for like terms and add them together. If you're subtracting, please distribute the negative to everything in the second set of parentheses before you begin combining like terms. Once you've distributed that negative, it really is the same as adding polynomials. You're just going to look for like terms and add them up. So again, I like to rewrite the problem just to keep everything really clear. Negative times positive 9x cubed becomes -9x cubed. -1 times positive 3x squared becomes -3x squared. Negative times negative is positive 7x. Negative times positive is -2. Okay, look for like terms. 7x cubed minus 9x cubed, that's going to be -2x cubed. I like to cross them out just to make sure I get all the terms. I've got -2x squared and -3x squared. -2 minus 3 is -5x squared. I've got 3 x's and I'm going to add 7 x's to that. I'm going to get 10 x's. And 6 minus 2 is 4. So again, because we started with the highest degree term and then went down from there, this is already in standard form. We have the third degree first, then the second, then the first, and then the one without a degree. So if you didn't do it in that order, it's fine. You can do it in any order you would like. Just once you're done, put it in standard form if you chose to do it in a different order. Let's see if I had another example. Nope. All right, so we're going to stop there. Go ahead and try the problems on your homework, and we'll see you next time.